Hello, Namaste. Welcome back to the course on Geography Information Systems. Uh, we were discussing about database management system. We looked at different database. We looked at different data definition language, data manipulation language. Then in the previous session also we looked at what is normalization and what is the need for normalization and the goal of normalization, and we looked at different the features, or let's say what do you mean by a key, the primary key, etc. We looked at all of those aspects. In today's class we would look at different models of a database management system. So there are different thinking, different aspects of how a database management system is handled, or a database is handled or managed. So we look at all of these aspects in or I'll give you a representative portion of the models which exist in terms of database management system in today's world. But these are essentially not covering the entire aspects of what do you mean by database management system models, but just a representative factor and just an information that you may need in case you are trying to look at more advanced things in GIS. Okay, so we would look at different database management system model, look at the pros and cons of different databases. Then we would also get into what do you mean by object oriented database management system. So we would also look at that as a last concept in this particular lecture. And when we look at different database management models that are available today, there is hierarchical database model, there is a network database model, there is relational database modeling system or model system. Then you have object oriented database management system or a modeling system. Then you have object oriented relational database management system. So these are very well known types of different database management systems. So there are a huge number of developed more interesting way database management system, which probably you can even look at on the web. But as of now, when we are looking at geographic information systems, so these are the very well used database management system. But RDBMS is the one management system that is well recognized and used by huge amount of users for their applications. So relational database management system is one that we would look forward when we are looking at the entire GIS package. So normally that is the one that is mostly used where in many of the GIS packages that operate in today's scenario. Okay, so the first type of database is the hierarchical database or the hierarchical database management system. When we look at hierarchical database, network bases, a combination of these are used whenever the data is to be stored in is restricted to a geometric data. When I say geometric, I am very specific to the geometry of a data. Okay, normally basic design of a database is divided into three categories. One is a standalone, Gantt, and another one is a joint. So these here when you see this is representing a standalone. So you have a particular database, you have a query mechanism, and that is how it is being accessed. So you again you have another database, another query, another database, another query. So but there is a Gantt network, which is a combination of different entities, different relationships in that entire database, and you have different users accessing it for different purposes that normally we discuss. There is a joint network wherein you have one Gantt network and multiple networks that are connected to this particular Gantt network, and each of this network having maybe it may be a standalone network, or again it may be another Gantt network having multiple users. This becomes a joint network. So combination of a standalone network, Gantt network, or many Gantt networks form a joint network. So joint database design provides the greatest benefit, but it is most complex in design. In terms of designing and maintenance of this database is also extremely difficult. And most importantly, security of the joint network is the aspect that one has to understand in order to maintain this entire database. Okay, so This is what about the hierarchical database. And similarly, when we look at the advantages and disadvantages, when we look at advantages, it is complexly simple, it has simplicity, okay. But when you look at the implementation part of it, it is highly complex, especially when you have a joint kind of hierarchical database. And when you are looking at database security and integrity, it is simple terms of implementation. But when you look at the standards, it lacks the standards in terms of whatever the data standards it has to represent, or the data modeling standards that it normally has to represent, okay. So when you look at data independence, the main advantage of hierarchical database, as normally we have seen with the database in advantage, it has data independence, but it lacks the structural independence. For example, it cannot have its own way of representation of the data, so the structural integrity is missing, so the independence is missing in terms of hierarchical database. And efficiency is actually missing. For example, when you have a huge joint network, it may have, yeah, the efficiency of that particular system is high, but it is highly complex in terms of programming. Efficiency is good, but it is highly complex, as I said previously, in terms of joint. Otherwise, if it's a normal standalone network, it's very easy in terms of both efficiency and complexity. But these systems are not preferred when you are accessing a different databases at different point of time. So you need to have either a GAN network or a joint network, which becomes complex in terms of programming. And when we look at applications and users, hierarchical databases normally are useful in storing file systems in your computer. It is storing geographic information, telecommunication, banking, computer operating systems. All of these are were used, but now most of the systems have gradually graduated into relational database management systems than hierarchical databases, or they have gone into relational databases usage, which has improved. So when we look at relational database management system, this is one of the very well used database management system. Most of the companies worldwide, well known companies, use the relational database management system, whether GIS or whether it is any other company related to working on a database or developing a database. Most of the companies use a relational database management system. Normally data is stored in a form of a tuples. When I say tuple or a tuple, so it is conceptualized as tables, okay, number of rows and columns representing the fields. So each table data is about a class of objects, okay. When I say objects, it's a two-dimensional list. Rows is nothing but objects, and columns is object states, that is the properties or attributes, that is called as fields, okay. So please remember this. So objects is when you have the object and the fields of that particular object, then it's called a tuple. So each of this rows is represented by object, and each of this column is represented by a field, okay. So that is representing attributes. So when we look at DBMS, as I said, 95% of the data is in the database management system is using the relational database management system. And we look at the commercial part of it, we have IBM DB2, we have Infomix, we have Microsoft Access, which is again based on the relational database management system framework. Then you have Microsoft SQL Server, Oracle, Sybase. So all of these are examples of using a commercial system for a relational database management system. And to give you an example of an database, for example, I have a primary key which is 42. Okay, this is a patient record in a hospital. Let us say we have an hospital X where we are trying to access this patient record. So 42 is the key of that particular patient, or a unique ID of that particular patient. The same unique ID, for example, for anyone, if it is not from the hospital, he or she wants to look at when the patient has come and where he has visited. For him, this particular file is quite enough, okay. So if if that particular person accesses this database, so he can see that patient 42 had checked in at this point of time and checked out at this point of time, and this was his room number. Okay. So, about 10 days. Now, if let us say a management person who is managing that particular hospital, okay, or particular system, has to look at what patient, how much, what does the patient has consumed, how much the consumables are required for that patient surgery or any of those aspects, and what is the total price. So, he or she will be gaining access to this particular table in the same database. That relationship is built with this particular key. So, this is a primary key in this particular table, and the same primary key is used as a key here, it becomes a foreign key. Okay. So, but the relationship is built with 42. Now, there is an administrator or let us say a police who wants to know the entire history of this particular patient. He or she may not need what is a purchase record of this particular patient. Okay. So, he or she only needs where the accident has happened, how, and what is the status of this patient, where it has checked in and checked out. So, this for example, a police inspector may get an access to this particular table along with this particular table. Okay. Whereas, a manager in the hospital who is looking at management records may get an access to these two things. Okay. So, this particular the police will look at the same key here, which is 42. So, if he puts in the patient name and he knows the key, so he is defining this particular key, and because of which he knows when the accident has happened, what is the name of that particular person, and where it was, where this is a location, and also when he was admitted to the hospital, when he was recovered from that particular injury, and where he recovered. Okay. So, he knows the entire database of it. So, this is what is a relational database. It is a relation that is built based on keys that is represented in each of these system. So, that just to give you an example of what relational database is, that I try to build upon this particular example. Okay. So, if we have understood this, let us move on. Then there is a concept of relational join. When I say relational join, it is a fundamental query operation. So, you are querying in terms of joining. When I, for example, let us simply think about join. What does join mean? If I have to join two things, which means that I am trying to build a relationship between these two things, right? So, that means to say that I am querying where I have to join, basically, whether I have to join at the end, whether I have to join at a particular point. Now, which means that I am trying to query a particular entity, right. So, it may occur because your data created, maintained by different users by integration, it needs to be queried, okay. Or for example, you have common keys in different tables, you want to merge all those tables to get a common output. For example, instead of a policeman, if I want to give him an output, instead of giving him 2-3 tables at 2 different places, I would give him the entire record, whatever he is able to access in a single table. So, just use this process of relational join, combine both of those tables which are represented, the first and the third table, and that can be represented as an output for that particular inspector or the policeman who is actually looking at it. So, that is what is the use of a relational join. So, table attributes join concept has been extended even in the geographic case. If you are looking at a geographic, if you want to join two different aspects or the geometries that are available in the spatial use, so that also can be used in terms of a spatial join, spatial relational join, if you are trying to use the relational database. For example, let me give an again an example here. Now, I have different addresses of different people. For example, I have a record number here, 1241 is a record number. Then I have a address that is corresponding to this particular record number, and there are different cars. For example, a person with 1241 record has 3 cars. A person with 1242 record has 1 car. a person with 1243 record has 2 cars, whereas a person with 1244 record has 1 car. So each of these records have different cars, but the very important point is this is represented in form of a geographical quantity, which means each of them have an address that is actually representing a geographical unit on the earth's surface. So this is a record, this is the address, and this is the car. Now if a person wants to know which are the cars that he has from the which company and when he bought, so probably using this particular record ID, he or she can access the number of cars, the car brand cars, and when he or she has bought this particular car, right. So now if I have to represent, for example, I make a query saying that 3 cars of 1241 address and the date of buying. For example, if someone was to query about that particular thing, so just with the query, if the join will join both of these tables, okay, and it would represent something like this: 1241, okay, address is 123 State Street, 3 cars, Ford, Subaru and Honda, okay, bought at 2003, 2000 and 1999. Okay. If again someone gives a query as color, if the color is there in other table, so that is also joined into it as red, green and black. So relationship join tries to give information by joining different tables and combining the information and giving it as a planar information into or a flat file information to the user who wants to access such informations. That is what is the use of a join. So when we look at pros and cons of a relational join, it is the most flexible as far as the database models are concerned. No obvious match of implementation of a particular model. Model is the user's view, not the way the data is organized. Okay. So whenever I am speaking about data models in databases, it is how the user's view has to be there. It is not about the data. Okay. Data organization is based on the normalizations and the database management system and not with the models. Okay. Is the basis of the area of formal mathematical theory. Most RDBMS data manipulation languages requires the user to know the contents of a relations. So that is what is very important. If you don't know the relation, what kind of the different relations exist and where it exists, probably that querying may not be very effective. Okay. It allows access from one relations to another through common attributes. So that common attributes has to be there in all the different tables. If that common attribute is missing, then your query will miss a particular table in the context. For example, the property, the address value, ID, country, and the same country will have country ID. So the ID is country ID is the common here. Then you have a name and tax rate. So if a person who wants to know a property details, he or she would be given access to only this. If someone wants to know the country details, he or she, where this property is located, he or she would know only this. But if a person wants to know the details of the country where the property is located and the details of the property, then both of this table can be related using this particular key that is common in both of these tables. One at one place it's a primary key, other place it's a foreign key. So based on this, you try to join that table and provide as a output. So that's how the relational database works. It's a simpler way of putting it, but when you look at the entire organizational database, it's quite complex in terms of maintenance. So when we look at the pros and cons, to answer the query, what are the taxes on a property X, the user would retrieve the property record first of all, then link the property and the county records through the common attributes county ID. Okay. If compute the tax by multiplying the value from a property tuple with tax rate from the linked county tuple. So that is what the user has to do. It doesn't give you the entire output as just if you want to compute tax for that particular property in the county. So, it does not give you an output, but it gives you the entire table where you have to probably use data manipulation languages or add an attribute information into that particular table. Okay. So, that is the pro of it is you can easily look at relations and join and the query whatever you need, but the con is that it is the user who has to look at all of these aspects. The next type of database management system is object oriented database management system. These system integrate database technology with object oriented programming paradigm. Okay, the most important promising technology of the next generation of database management approach is in the software development. Object oriented is one where every object is treated as a different entity. Okay, each entity has a different table, and each wherever you have an object is connected through a relation, and each of these relations can be modified. That is again object relationship database management system. That is also another kind of a database management system. So, when we look at object oriented database, we have objects and identities. Each real world entity is modeled as an object. Entity is modeled as an object, and each object is associated with a unique identifier. That is very important. It always has a unique identifier, and you have, as in object oriented programming, you have classes here. All objects which share the same set of attributes and methods are grouped together in classes. Okay, each object is an instance of a class. Each object is an instance of a class. Okay, and then the ability of an object to hide its data and methods from the rest of the world is done using encapsulations in object oriented database management system. It has a property of inheritance, which means a class can be defined as another instance of one or more existing class with attributes and methods of such classes. Okay, overloading, overriding, late bending. So, these functions, different methods can be associated with the same operation name. Okay, in terms of object oriented databases, which is not possible in relational database as such. And when you look at extended relational systems, this trend in closer to relational databases, that is object oriented relational database management systems. These are extension of relational database management system, and with various functions, triggers, actions that are automatically executed by a system when specific condition rise, which was an disadvantage in terms of a relational database. It is also a deductive database management system. These systems integrate a database technology with a logical programming. If you have a logical programming or a logic programming into it, so it gives you a deductive database management system, and also provides an intelligent database. Today, order of today's day is providing an intelligent database management system that it can provide, it can incorporate an artificial intelligence into it. It can have different various fields of where the technology is imported in terms of a database management system or managing the entire database and providing queries to the user in much useful way in terms of user manipulation or user usage is reduced, but you get our query in a much easier way. Such things can be done using a intelligent database management system in terms of object oriented database management system or an object oriented relational database management system. On a note, when we look at database, the primary goal to pull it up together, the primary goal of a database system is to provide an environment for retrieving information from and storing new information in the database. Okay, successful database design involves normalization basically. So, different types of normalization also we will look at. Database normalization helps in design of a new database to meet the goals or test the goals in terms of data integrity and referential integrity. So, keep this in mind. So, data integrity and referential integrity are very important. Finally, normalization ideally occurs before creating a database. However, normalization can be used to test the existing databases. So, this is about what we learned in the entire database systems. In the next class, we would be looking at what are different normalization techniques, what are different normal forms, okay, how do we start with a database, how do we convert each database into different normal forms, and finally end it with the best normal form wherein the database can be easily, and it is much quicker, and most importantly it is more efficient in terms of handling. So to summarize today's class, so we looked at the types of databases. We first looked at what is a hierarchical database, we looked at what are the pros and cons of that particular database, then we looked at relational database, the how the relational database is advantageous in terms of all the database queries. We looked at it as pros and cons. Also we looked at the major con is that it cannot give you the final output that you would expect, but it would give you the entire data wherein the output has to be manipulated by you as an user. And we looked at the object oriented database, object oriented relational database, wherein objects, the entire entity is converted as an object, and it has different ways of access and usage of including artificial intelligence techniques or intelligent database management system in order to provide outputs to the user. So this is about different data models. So in the next class we will look at normalization, as I said previously, different normal forms, and probably end this database session with giving you some examples of that. Thank you very much. Till have a nice day or time till then.